Okay, I did the math on number 10 and I figured out that the width would be 120, that the length would be 180 feet, and therefore the maximum area of this playground would be 21,600 square feet. Okay. Next, number 11 is very similar, and I'm actually going to do this on a piece of scratch paper so I don't have to squish it all in there. So number 11 says, you have 108 feet of fencing to enclose a rectangular plot that borders on a river. Okay, so this is 11. Here's my rectangular plot, borders on a river. Okay. If you do not fence the side along the river, okay, find the length and width of the plot that will maximize the area. Again, I'm going to label my sides. I let L equal length, W equal width. Okay. Again, I'm going to start with the equation that has to do with the fencing. This time, L plus 2W equals 108. Notice it's only 1L because only one length is fenced along the river. We don't have to put a fence. Sometimes people ask, well, does it matter if I called these sides L's and this one W? It doesn't matter at all. You're going to get the same answer. Okay, the second equation I'm going to write is that I'm looking for a maximum area, and I know the area is length times width. Okay, now I'm going to substitute. I take the equation over here. Since area is what I want to maximize, I want to work with this, with the area. I can't have both length and width, so I use the fencing equation. I'm going to solve for length, get 108 minus 2W, and I substitute, and now I have that area is equal to 108 minus 2W times W. Now let's distribute and write it in the correct order. I should get negative 2W squared plus 108W. And now remember, I want to maximize the area, so the maximum will occur at the vertex. So the W value at the vertex will be negative B over 2A, which would be negative 108 over 2 times negative 2, which is, wait, don't tell me, 108 divided by 4 is 27. Okay? Now, this time, they say, let's read the question again. The question says, there, find the length and width of the plot that will maximize your area. They don't ask me for the actual area, just the length and width. Well, I just found the width. To find the length, I go 108 minus 2 times 27, and that would be 54. So now, on my nice handout here, I'm going to write my answer in a complete sentence. And it says, should say, the plot should be 27 feet by 54 feet. And that's how I want to see your answer, of course, along with all that work that you showed there. Okay, number 12 is actually very straightforward. It says, the daily profit in dollars of a specialty cake shop is described by this function. They give us this lovely function. P stands for profit, and here's the function, and it says where X is the number of cakes prepared in one day. So X represents the number of cakes made in a day. The maximum profit for the company occurs at the vertex of the parabola. Look, they're even telling us what to do. How many cakes should be prepared per day in order to maximize profit? What variable was cakes per day? X. They are saying find the X value of the vertex. So, negative B over 2A. You guys should have this memorized by now, right? Having bad dreams about it yet? Okay. 2 times negative 4. So I get, I think we get 25. And that's it. They didn't ask what the maximum profit was or anything like that. They just said, how many? So you would write, and let's be correct, at least pretend like we're correct, 25 cakes per day should be prepared. Done. Okay, now I always put 13 in here to really emphasize that you need to read these questions carefully. Okay, so let's read 13 carefully. An object is propelled vertically upward from the top of a 144-foot building. Okay, so you're on top of a 144-foot building and you throw a ball up in the air. The quadratic function, and they give us a lovely quadratic function, models the ball's height above the ground, s of t, so s represents height in feet, t seconds after it was thrown, so t represents time in seconds. How many seconds does it take until the object finally hits the ground? Round to the nearest tenth of a second if necessary. Okay, how many seconds does it take, we're looking for time, until the object finally hits the ground? We're looking for time, so they need to tell us about the height. Well, they told us we want our object to be on the ground. What's the height of an object on the ground? 0. Okay? So this has nothing to do with the vertex at all. But we do problems that look like this that do have to do with the vertex. So I can ask you a couple of different things about this. This is called projectile motion, and you'll see these. They'll look familiar after a while. I can ask you how long until it hits the ground. I can ask you its maximum height. I can ask you what time the maximum height occurs. Okay, let me think. I'm sure I could ask you some other stuff, but we'll stick to those for now. All right, the first thing I'm going to do on this one is I'm going to factor out negative 16. T squared minus 10t, and that'll be minus 9 equals 0. Now I would like to caution you. It really looks like we could factor this, doesn't it? Because you go 9, oh, 9 and 1 would be 10. Okay, but the negatives throw us off. You cannot factor this. You have to use the quadratic formula. Now the good news is, since that's a constant, I could divide both sides by negative 16 and it would be gone, right? It doesn't affect the rest of it when I use the quadratic formula. So this time it would be t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I will let you guys plug that in and figure out what the answer is. I don't remember, but I know it's on our answer key. Okay? All right, that's 3.1.